but this was no flying saucer.
Okay, this is a CRT tube that I have prepared for you guys to be able to see it better. I have removed the horizontal, and I have also removed the vertical coils off from it. As you can see, there's only one core here, and that it's within the upper and lower for the vertical deflecting coils. Now here what we have is just a plain tube fed by the positive anode right here, and it's just being fed as a dot on the screen, and I am fitting it with that PSU right there, so it's about 11 volts and 0.44 440 milliamps. Right now what I'm gonna do is start approaching a North Pole, which is the blue polarization, and as I go from the center of the screen straight, you see how it deflects down. Now this is a neo, so it's got a pretty long range of field volume, so you can see it starts acting at a pretty long distance there. Now as I approach the other magnet on both sides, you could see that it will stabilize and it will accelerate a north and a south. Now I'm going to be approaching the North Pole from the right side of the tube, and you can see how it goes up. I approach it straight towards the tube, it goes up. And of course, if I go with the opposite pole, they complement each other. And you guys could see, move this, make it even here, and you could see how they accelerate going up, straight up. Okay, now for simplicity, I just, and easy because I cannot put the thing up and had to put it with a non-magnetic stand. So what I have done is just turn the monitor, the CRT, sideways so I can project from the top with the north. I'm going to be approaching from the top of the tube, and you guys are gonna see how it moves to the left of the screen. Now if I add the south on the other side, on the opposite side, it's just going to balance the movement. You see it much more straight because both spirals will be balancing the electron beam, so it's a more linear movement. Okay, so now I'm going to be approaching with the north from the bottom of it, and we're going to see the opposite movement, and cannot get that close because the glass is right there. But now when I come with the south on this way and I approach from both upper and lower, we can see how it travels more stable, and even from a further distance, the north takes the dot with the assistance of the south all the way to what will be on the right side of the screen. Okay guys, I have already connected the horizontal deflecting coils, and these are the two there are actually two coils in series, as you saw on the diagram. And I have the signal running through channel 1 on the scope, and you could see they are not exactly the same because it depends upon the equipment and the type of, besides the fact that it's not but you can see that it's not perfectly square above, but it's on the positive side it's kind of small related to the south, to the negative one. But the point is just to show that it's running. You can see the PSU is consuming a little bit more, double I would say, 870 milliamps and 11.4 volts, a little bit more of amperage. But here we have a horizontal line, and yeah, let me take some intensity off, and just gonna turn this light off so it could be seen better. Okay. Now you see the line doesn't get all the way to the edges, the sweeping line, because it doesn't have any ferromagnetic material. And I'm just gonna add this core from the other, and you see how it widens. It widens pretty much. And of course, if I put the lower one on, it gets almost all the way to the sides of the screen. So, but that'll be enough for the purposes of watching what we. Let me take some brightness off. And now let me approach a north magnetic field, and you would see that it does. The positive on the upper quadrant, and this is where I want to make sure you understand. This is where actually the vortex is hitting the line, constantly hitting it, even though it's running a very high frequency. It's about 15 kilohertz, and on the other side is hitting it right here. And this is what I talk about on the video about the floating center line. It's, you can move it and relocate it, but you know, it looks like flexible. And this is the magnitude of this deflection here. You could see it right there. And a smaller magnet, and I'm gonna get this little cube right here, which is it's a Neo. But you guys will see what kind of deflection that is a north. and you see what kind of deflection it's doing right there. Very small. This little vortex, it's right there and right here on the edge. And of course, depending on the magnitude, it'll be doing a higher. And like I also said on the video, as soon as I retract the line, it comes back flat again. And this is the north. Upper quadrant is positive sign. Lower right, it's a negative. And like I also said, if I approach it, you guys would see like a number 8 right there on the screen, which is, and it just fractions the line into 1 there. It won't return it, it'll break it. But in order to see it clear, it's just keeping a distance. It'll be enough to be able to see it from both angles. This is a north pole, so it creates a clockwise on-screen rotation. If we look at it like this, it'll be counterclockwise to us. So this is all relative. And now I'm going to approach the magnet from the south polarization facing the beam, and you could see what you saw on the 3D animation graphics. It's gonna be a counterclockwise on-screen sine wave. You can see right here, this is the point where it's doing, and this is actually the angle of deflection that it's doing. And that's the angle right there. And as I go out, the angle, and this also works for electromagnets when we pulse them. So this will get interesting, very interesting in the future. But here, these are just the basic points here. It's negative deflection, left lower, and right upper is a positive deflection, as you saw on the video. I just forgot to mention that about what we can do with this coil by moving it, and what I have done here, it's I have added both coils, cores from the vertical coil, deflecting coils, which are not connected, but I'm just putting it for the use of the core, and I have a very wide line right now going from one end of the screen to the other. And the point here, it's that I want to make sure you understand, this is by moving this coil, you can go all the way and make it vertical. And making it vertical, it doesn't at all, it doesn't disturb what you have observed before. So this is a north. It will keep deflecting the same way, and this is very important you understand. It's doing a positive and a negative on the bottom, so it really don't change the direction of the north spiral, which is going clockwise on screen, and if I turn it to south, it will do the same thing. It'll do the same thing as shown with the horizontal. It'll be a counterclockwise spin, which you can see right here. So it really don't matter the position of the rastering line. It will still show the same movement, and this is very important because we can adjust it and we can get it back into horizontal. I just use horizontal for minimizing the video time.